everyone, and welcome to another episode of Tea with B&D. I'm your host, Laura, and each week we discuss topics related to heavy industry, heavy manufacturing, and my personal favorite pairings of tasty teas and delectable delights. So grab yourself something hot and let's get started. So for this week's Tea of the Week, I decided to keep it real simple and go with an organic black tea. And so I wanted to share with you guys how I make my tea, because although the instructions say to steep for 3 to 5 minutes, I usually put the bag in, pour the hot water, let it steep for 5 minutes, but then I never take the bag out because I like my tea to be really, really strong. And if you don't steep it long enough and you add the milk and honey, it is just going to be almost watered down tea, and I don't like that. But if you like that, cool, float your boat. But for me, the tea bag never comes out until the drink is done. And for this week's delectable delight, I decided to keep it local and go with a bakery here in Middle Georgia called Wilson's Bakery, and they have the best desserts. These are their finger cookies, and they're almost like thin, buttery pecan shortbread cookies with the perfect amount of icing on the top. And take a look at that. It is so good. And today's episode is all about seals.
And no, not this kind of seal.
Mechanical seals. The general purpose of an oil seal is to protect shafts and bearings by keeping dirt and foreign matter from entering while keeping grease or oil from escaping. An oil seal generally consists of an outer circular metal part and an inner flexible member that does the actual sealing. A fine sealing edge provides adequate pressure to the shaft to prevent leakage. So let's look at some of the common types of seals found in the industry. The first group of seals are called contact seals. Typically, these must withstand the strain of ongoing movement in conditions where they are exposed to grit and contamination. The two types that we have shown here are lip seals and double lip seals. Double lip seals have a secondary sealing lip, which prevents contaminants from entering the system. The next category of seals are called bearing isolators. Bearing isolators are non-contacting labyrinth-style seals. They are used where there is no concern of having a flooded shaft condition. Isomag is one example of a bearing isolator. These create positive, long-term liquid-tight seals. These close the leak seals inherent to labyrinth seals by incorporating a magnetically energized flat-face contact surface, creating a positive seal without wearing the host equipment. Proper insulation and alignment can be crucial for successful operation. The second type of bearing isolators are in-pro seals. In-pro seals are a two-part dynamic seal. This bearing isolator has a stator and a rotor working together to create a non-contacting compound labyrinth seal with no wearing parts. When the gearbox is at rest, the in-pro seal seals the labyrinth, blocking condensation and contamination from entering the bearing housing. During operation, centrifugal force lifts the ring away from contact with the stator to create a non-wearing permanent seal. And the last group of seals we'll discuss today are non-contacting seals. These have a series of grooves that are close to the shaft but don't touch it. As the oil travels through the labyrinth, it experiences a pressure drop that prevents the oil from leaving within the gearbox and travels back to the sump. There are many different seal designs based on the application of the components. The operation parameters of the components are essential in providing the right seal for the right application. Shaft speed, operational temperatures, and environment are the operational parameters needed in order to determine the correct seal. Rotational shaft speed and diameter determines heat transition due to the seal contact area. These speeds vary considerably from minimum to maximum motor speeds in each application. In regards to operational temperatures, most gearboxes have an operational sump temperature of around 140 degrees. The more modern gearboxes are designed to operate around 160 degrees or higher due to metallurgy advancements. These gearboxes are normally smaller and are of cast iron construction. Thus, the use of fans and/or external or internal cooling systems Combine these operational temperatures and friction created from the seal selection becomes critical for long-term reliability. Gearboxes and rotating equipment can be required to operate in many environments. These conditions can vary throughout many diverse industries. Some of the industries where these challenges are faced are aggregate and mining, or cement. They have very abrasive conditions. Pulp and paper. They have higher than normal ambient temperatures with very corrosive atmospheric conditions. Building products and chip mills. Inconsistent loading with flexing of the supporting base, which allows for the shafts to rotate out of parallel axis, creating eccentricity between the seal, surface, and shaft. And the last area is tissue and hygiene products. These applications are designed for no lubrication leaks due to damage to the products. Special conditions to seal choices are critical. Even though the process includes corrosives and high operating temperatures in certain area of the process, the exact area of the application needs to be clearly defined to select the appropriate sealing device. These are some of the more prevalent industries that we serve. Unfortunately, all applications need to be clearly defined with specific operation parameters to provide the best sealing options. So that's all the time that we have for today, folks. Now that you have an intro to oil seals, time for me to seal my mouth shut from eating more of these delicious cookies. I'm pretty sure I've eaten about 7 in this whole filming production. Tune into the next episode as we discuss seal root cause failure and some of our own GRS designs that we've done for our customers. Have a great day.